Hi, I'm Bob Tabor with LearnVisualStudio.net. This is part 2 of the Cheater's Guide to XAML. We've created simple examples of XAML up to this point, and we've been explaining the unique qualities of XAML through these little examples. So let's continue on. We stopped where we had created a stack panel with several buttons like you see here in the code portion of our XAML editor. Since we're essentially working with an XML document, we can embed elements inside of other elements. So here the stack panel contains several buttons, or perhaps more correctly in XAML parlance, stack panel's children collection includes several instances of the button class. We're able to do this because the stack panel has a children property, and that children property is the default property for the object. So depending on the type of object, or in this case control, that you're working with, the default property can be populated using this embedded style syntax. So let's create another button, for example, and we can create a fourth button by merely placing the text, which would typically be the content property, but we can just place it in between the opening and closing button element tags. Since the content property is the default property of the button class, this works. Now we can have a little bit of fun and style this up. If you recall, if it has a content property, then we can put a stack panel in there, right? And then we can also put our text block inside of there with our text equals fourth button. And you might say, well, that's not much of an improvement. It looks about the same. Yeah, but now that we have a stack panel, we could like add an image, and we could set the source equal to, and if you ever have a problem setting the source, because sometimes it's challenging to figure out where things are located in your project, we have an assets folder that has some sample assets, for example, the logo, the small logo, the store logo, things of that nature. Again, just so that when we go to the start screen, it has something to display here. But what we can do with our image controls, go over to the properties window and just use this drop down list to select one of these. We should be able to select small logo, I think, yeah. And we get a little box with an X through it, all right, just a placeholder for us. And we can set the width equal to 20 and the height equal to 20. And now we have an icon sitting on top of our text block. But if we were to change the orientation to horizontal, now we have the little icon sitting next to our text. And if we thought that these two lived a little too close to each other, we could add a margin between them. And so I could put like 10 pixels to the left of the text block, and then 0 on top, 0 to the right, and 0 to the bottom. But that would give us a little space between the icon and the text itself. And now we have a more stylized button. And so I guess the point of this is that twofold. First of all, it's really easy to style up any control that has a content by using stack panels or grids in order to kind of build the little compartments or pieces and kind of assemble it together. But I think the larger issue here is that we were able to use the default property of the button in order to set the content to do something really interesting. Well, some properties, like for example content, can be set fairly easily if all we need is a string. But some properties are not easily represented and are referred to as complex properties. So take for example the grid row definitions and the grid column definitions that we've already created. Here it wouldn't be very easy to set the number of rows and columns that we need and the sizes of those columns in the element itself. So we break out and create elements that allow us to create more interesting or complex definitions, in this case for rows and columns. And so this is called property element syntax, and it's in the form of the name of the control and then a dot and then the property that you want to set. So a good example of this is if you were working with a linear gradient brush. And what I want to do is I'm going to add a ellipse into this area right here. You know what an ellipse is, right? It's just like an oval shape. So we're going to set its grid.column equal to 2. All right, and so now we have an empty ellipse. And if I wanted to set its fill property, I could just set it to red. And now I have a red ellipse on my page. But what if I wanted it to be a little bit more interesting than just the color red? What if I wanted there to be a gradient that goes from red to purple to blue, or red to green to blue? All right, in that case, I'm going to have to get a little more creative here and set the fill property using this property element syntax. Furthermore, I'm going to use a different type of brush. Like by default, we're using the solid color brush red, but now we want to use a linear gradient brush. And when you think of the word brush, it's just like a paintbrush that you would paint an object with. Now this particular brush that we're going to use is kind of a magical brush. It allows us to paint multiple colors on a given surface, and start with red, then move to green, and then move on to blue, and it'll perfectly be distributed across the width or the height of the given object that we're painting. So we're going to create a linear gradient brush, and I don't really want to get into the details. The linear gradient brush isn't as important as the larger lesson involved here, so please stay with me on this because I got a point I want to make. And so you see, if we want to define a linear gradient brush, we have to supply a lot of information in order to render the brush correctly. We have to give it the colors, at what point the color should break into the next color, and so on. The linear gradient brush has a collection of gradient stop objects which define the colors and their positions in the gradient, or in other words, their offset. That's not exactly true, however, because the XAML that represents the linear gradient brush has been shortened. And so let me show you what it should really look like if we were being really persnickety and picky. We would, inside of the linear gradient brush, set a series of gradient stops. And the gradient stops would actually be a gradient stop collection object, which contains a number of instances of gradient stop. Okay, so and that's really more correct. If we were to do this in C#, there would be more lines of code because we would be creating instances of, for example, the gradient stop collection, and creating new instances of gradient stop. So how are we able to get away with not adding some of this extra XAML in here? Well, it all works. And I think the moral of the story, if you will, is that XAML allows us to create instances of classes declaratively, and we do have a granular fidelity of control to design user interface elements. But even so, the XAML parser is intelligent enough that it doesn't require us to include redundant code. It knows that if we're trying to set gradient stops, that we can exclude all this extra stuff, right? All we need to do is provide it enough information to create the object graph correctly, and it will fill in the blank spots on its own. All right? So that's pretty cool. Again, it gives us this ability to write things very succinctly. All right, so I've been using these terms like ellipse and gradient stops and buttons and stack panels and text blocks and text boxes and grids and so forth. Well, how many XAML controls are there exactly? Well, if you take a look at the toolbox and you can drill down into this all XAML controls, you can see that there are Well, quite a few. There are things that we will never use in the context of this project, like, for example, the checkbox or the combo box, the ellipse, the hyperlink button, or the pop-up. And yet these are elements that you might find yourself using often whenever you're building real applications. So, for example, if we wanted to add an ellipse just using the toolbox, we could drag and drop it to somewhere on the designer. Now let me just get over to a nice safe area here. And I can drag and drop the ellipse and stick it in here. And you can see now it's part of our page. We can see its definition right here. And it kind of filled in the blanks based on what our previous ellipse was looked like. All right. Or I could just go to the toolbox and I can drag and drop an item from it into the code window, and it will create a little stub for us, which we can work with then. But you'll notice that most of the time I like to type everything in by hand. It gives me control. It forces me to understand what I'm trying to do. I never use the designer. I don't know that of any professional developers who use the designer surface, so you need to get into the practice of using the code editor and using IntelliSense and all the help that you get from IntelliSense in order to be building your user interfaces. All right? So, you might ask yourself, well, how am I supposed to learn all of the properties or attributes of a given element? I mean, there's so many to learn from. Well, I think what you do is you have an idea in your mind of what you want it to do, and then you start doing some detective work. For me, I will just start, for example, with ellipse, and then I start looking through the IntelliSense and just kind of going through it and I think, that sounds like something I might be interested in. So then what I do is I open up Internet Explorer and I go to bing.com, and then I use that little trick I talked about earlier with site:/Microsoft.com or site:/dev.windows.com, and then I search for some class or some attribute, and then I start looking at all the links that might sound useful to me in order to learn about a given attribute. Okay? All right, so let's go ahead and get rid of that. And let's wrap up this Cheater's Guide to XAML by talking about what exactly it is that makes XAML XAML. And we said that XAML is simply just a flavor of XML that was created by Microsoft so that you can succinctly create instances of a class, like user interface classes used for the layout of your Windows Store app, or the items that are inside of it, like our buttons and so forth. Okay? So to use XML, typically what you do is you define a schema, which declares the proper names of the elements and their attributes. A schema is like a contract. Everybody agrees, both the producer and the consumer of the XML, to abide by the terms of the contract, the rules of the contract. And so the producer of the XML says, I promise to write XML according to the rules. And that allows those applications that are going to be reading that XML to rely on those rules. And so now they can communicate with each other because they have a common language, they have a contract, an agreement, something that they can both look to and say, these are the rules of this given type of XML that the developer created. So a schema is an important part of XML. So where does XAML promise to adhere to a schema? Well, take a look at the very top of the main page.xaml page, all right? And so here at the very top, we have a number of these XMLNS. That's short for XML namespace, okay? And you can see the first one is to this schemas.microsoft.com/winifx/2006/XAML/presentation. So I have a bright idea. What if I were to hit Control-C to copy this and then open up Internet Explorer? I'm going to navigate to it so I can read the instructions of XAML. And so when I go there, I get an error. All right, well, what's up with that? It doesn't exist. That's because the schema is not published in the sense that you can go to a URL, like a web page, and view it. It's simply a unique name, and that's all it is. And it's used the way that we use namespaces in C#. It's simply to identify a given usage of a term. So remember when we were in the fundamental series talking about namespaces, there might be multiple classes that have the same name, but you can differentiate them based on their namespace. Well, this is sort of the same thing. The namespace keeps these class names all sorted out, kind of like a last name or a surname. So in this case, the URL that I'm going to repaste back in here is not really a URL, a Uniform Resource Locator. It's actually a URI, a Uniform Resource Identifier, and it's used as a namespace identifier. It's just the name of the agreement, the name of the contract, the name of the schema. It's not the actual location where that schema is defined necessarily. And that took me a little bit of time to really digest and figure out when I first heard it. The XML namespaces are instructions to the various applications that will parse through the XAML. For example, there are several consumers and producers of XAML, even within our little example here. There's the Windows Runtime XAML parser that looks through the XAML and tries to create executable code as a result of it. And then there's also Visual Studio, or if you were using Microsoft Blend, and it needs that information in order to render that to screen and be able to give it syntax highlighting and things of that nature. So it uses those schemas in order to give us a rich design time experience. All right, and so here this second XML namespace also has something a little curious about it. It has an X before it, and we see that we've used this X colon whenever we gave our grid a name, like layout grid. And so any elements or attribute names that are preceded by the X prefix means that they adhere to this second schema. So what's the difference between this first schema and this second schema? Well, the first schema defines the rules or the contract for Windows 8 app specific usage of XAML. In other words, the fact that we can work with the page, the grid, the text block, and all the other elements that we were working with without any of this prefixing means that they all are defined, or their rules are set up in this first schema. However, anything that is prefixed by this letter X means that it was set up in this second schema. And this second one defines XAML, or rather the rules of XAML in general, to be used across all usages of XAML in a very generic way, whereas this gives us specifically how it's to be used for Windows Store apps. Okay? So we see there are two other namespaces here. There's one called D and one called MC, and we'll learn about those a little bit later. We'll see how they help the designers within Visual Studio and Microsoft Blend, but let's ignore those for now. And actually, this is a good place to stop. I know that there are some questions left unanswered. We could spend a lot of time talking about all the nitty-gritty details and the specifics of XAML, but this was just a cheater's guide, right? If you understood what I said throughout the last two lessons, then you can lean on that knowledge throughout the rest of the series with little additional information, and you'll be just fine. But lucky for you, we're not done with XAML, because in the next lesson we're about to learn a few more features of XAML, including layout and how to interpret and use the binding syntax, and we'll revisit our grid app project and see how it's used there. So we'll see you in the next lesson. Thank you.